Question number 1, part A3. This last time I told you this topic, this process of forming alcohol or ethanol from sugar, it's called fermentation. This is not a method of separation, it is a process of forming alcohol from sugars. You will learn about fermentation in organic chemistry. Then page 8, question 2. Mention the page number as well so it is convenient. Page 8, question number 2. You have a nickel sulfate .6H2O, which is blue crystalline solid. Plan an experiment to obtain a sample of pure water from this salt. Your answer should include a diagram of the apparatus and expected observation and the test to show the presence of the pure water. So what will be the figure, the diagram? You will have a container or a flask. And you have solid nickel sulfate, hydrated. Hydrated means this contains water, water droplets. Then you will have a thermometer and a condenser is there. The beaker at the other end. This is a jacket of the condenser. So water will enter here, cold water, and after observing energy, it will go out from other side. So what we will do when we supply heat energy, these solids, nickel crystals, they contain water. So the water molecule will escape from the crystals and the condenser will remove the energy. So what we'll obtain? We will obtain pure water at the other side. What is the test for the water? How you can test the water? You can check the boiling point and it will boil at 100 degree centigrade. And expected observation, what you will observe? So this nickel sulfate .6H2O is blue in color. So whenever a compound loses its water of crystallization, the compound will show a color change. So the crystals of nickel sulfate will show a color change. Is it clear? Page number 5, question 2, and then this was page 5, question 2. Starting with sample of amino acid, describe how to separate, detect and identify the monomers which make it up. Your answer should include name the process. So which process we will use? The technique which is used to separate amino acids. That technique is called chromatography. the method used to detect the monomer after they are being separated. So what we will do, we will use chromatography. Then after using a chromatography, we will place amino acids. Amino acids are colorless on chromatogram. Place, draw the origin. Place amino acids on chromatogram. Then use suitable solvent. Then because these are colorless, so spray with locating agent, which will make it visible. So that's the answer for the second part. You use a locating agent to make them visible. Then how you'll identify, how to identify these amino acids? So you will measure the RF value and write the formula for RF value. RF value is equals to distance moved by the spot divided by distance moved by solvent, and compare the RF value of experiment with standard RF values of amino acid. So basically you will measure the RF value, and that RF value you will compare with a standard RF value to identify which amino acid is present. Is it clear? Question number 4, part C. Page 9. Why the thermometer bulb plays as shown, not in the mixture? What is the reason for that? Because the thermometer, we want the temperature of the vapors, not the temperature of the mixture. Because what vapors are leaving the tube, we want to identify the temperature of the vapors. So what is the purpose why a thermometer bulb is shown like it is not placed in the mixture? To measure the temperature of the mixture, because this position will measure the temperature of the mixture, so as, or the vapors basically. So we use it to measure the temperature of the vapors which are leaving. Question number 4, part E. Suggest a simple chemical test to show liquid collect is ethanol and not water. So test for ethanol, chemical test, ethanol, alcohols can catch fire. So check with a so how we can test an ethanol? You can either test or have test for water, or you can also test for ethanol. Chemical test for ethanol or any alcohol. Alcohol can catch fire. So you can check with a matchstick or a lighted splint. If alcohol is there or ethanol is there, it will catch fire because alcohol is a flammable liquid. It can burn. Give a physical test to identify pure ethanol. So how you can test? Physical test like boiling point or melting point. Ethanol is a liquid, so we can check its boiling point. So when you will check its boiling point, it will have a fixed boiling temperature. Is it clear? So physical tests are boiling point, melting point. Page 6, part C. Magnesium sulfate from aqueous magnesium sulfate means you have a magnesium sulfate dissolved in water. Because when we say aqueous means you have a salt solution or solution of magnesium sulfate. Aqueous magnesium sulfate means solution of magnesium sulfate. So how I can obtain a salt from this method? I can use either evaporation or I can use crystallization. So the technique, the method which we will use to obtain this, we can use crystallization. And then you have to explain crystallization, like what happened. And next is why this process works. So use crystallization and what will happen? Heat and concentrate the solution. Then cool the solution. And then filter to remove crystals. Explanation means why this will work, with this technique will work. Because the solubility, small amount of liquid can dissolve small quantity of solid. That is why crystals will form. So small, because what happened? First we have a container which is filled with a salt solution. We supply heat energy. So when we supply the heat energy or when we heat this, the amount of the liquid will reduce. As the amount of liquid will reduce, a small quantity of a solution can dissolve a smaller amount of salt. So what happened to the salt originally which was dissolved? The crystals of the salts will reappear. Anyone else having a doubt in this? Exercise 1 of separating mixtures. glycine for a mixture of two amino acids, glycine and alanine, and has a RF value. So the procedure, the technique which we'll use chromatography. And why the two types of amino acids are separated from each other? Why the two types of amino acids are separated from each other? Because they have different solubility. The one which dissolves more will rise to a greater height. The one which dissolves less will not move too much. So why this technique will work? Because two amino acids have different solubility in solvent, which gives different RF values. The two amino acids, why they rises to a different height? Because why they rises to a different height? Because they have different solubilities. Is it clear? Anyone else having a doubt? Okay, this is exercise 2. This will be a weekly homework I will share after the class, but some questions we will solve from this. In the question, a list of techniques used to separate a mixture is given below. Chromatography, crystallization, diffusion, evaporation, filtration, fractional distillation, and simple distillation. From the list, choose the most suitable technique to separate the following. If we need water from seawater, which technique is suitable? If we need water from the seawater.
Filtration.
If we need water from seawater, then simple distillation is, because if we need liquid from the solution, then the most suitable technique is simple distillation. So simple distillation will be here. Helium from mixture of helium and methane, both are gases. So which technique?
Fractional distillation.
Yeah, fractional distillation can be used, and because both are gases, so diffusion can also be used. Both answers are valid. You can write any one of them. Ethanol from mixture of ethanol and propanol means when two identical or same type of compounds are there, ethanol is an alcohol, propanol is also an alcohol. So it means they are miscible, they can mix with each other. If two miscible liquids are there, which technique we can use?
Fractional distillation.
So we will also use fractional distillation. Iron filling from a mixture of iron filling and water. If we need piece of iron from water, what we can do? Iron is insoluble, does not dissolve.
Filtration.
So the technique which we'll use filtration. A mixture of two amino acids, glycine and alanine. So when two amino acids are there, which technique we use?
Chromatography.
Chromatography. So we'll use chromatography. So it's not necessary that all the options which are given you have to use. Any suitable technique you can use. A list of technique used to separate the mixture. Butane from a mixture of propane and butane. You can see they're identical compound. How identical? Like same type or same nature of compound. Ane, propane, butane. So they're identical type of compound. Which technique we can use to separate them?
Fractional distillation.
So we can use fractional distillation. They will have different boiling point. Oxygen from liquid air.
Fractional distillation.
Fractional distillation can be used or diffusion can be used, but most suitable is fractional distillation. Water from aqueous magnesium sulfate means we need water from magnesium sulfate solution. We need water from magnesium sulfate solution.
Simple distillation.
Simple distillation. So if we need liquid from a solution, we use simple distillation. Potassium chloride from aqueous potassium chloride means we need a salt from salt solution. Salt from salt solution. Yeah, which method can be used?
Crystallization.
Yeah, crystallization can be used to obtain salt from salt solution. Silver chloride from a mixture of silver chloride and water. Silver chloride is insoluble salt. Silver chloride does not dissolve because I gave you a table. You have to learn. Most chlorides are soluble except silver, mercury, and lead. So silver chloride is insoluble salt. Which technique we can use? Which technique can be used? Filtration, diffusion, fraction distillation, crystallization, chromatography. If we need insoluble salt from the solution, so if we need insoluble salt from the solution, we can use filtration. Glucose from a mixture of glucose and maltose. So we can use chromatography for this. Amino acid mixture of glucose, we use chromatography. Question number 4. The following techniques are used to separate the mixture. Methane from a mixture of gases, methane and ethane. Which method is suitable?
Fractional distillation.
Yeah, fraction distillation. So the technique which is used here is a fraction distillation or diffusion. Both are acceptable. So you can write diffusion or you can write fractional distillation. Water from aqueous magnesium sulfate. We need water from magnesium sulfate solution. Water
The
from aqueous
distillation.
mixture. So we will use simple distillation. Glycine from a mixture of amino acid, glycine and lysine. Which technique can
Chromatography.
be chromatography? Iron filling from a mixture of iron filling and water.
Filtration.
Filtration. Zinc sulfate crystals from aqueous zinc sulfate means we need a salt from salt solution.
Evaporation.
Evaporation or crystallization, but crystallization is not mentioned here, so evaporation is only answer. Hexane from a mixture of liquid hexane and octane. So same type of compounds are there, and miscible compound.
Fractions.
So we'll use fraction distillation. Is it clear?
Yes.
Then remaining I will give you as a homework, so you will solve and discuss doubts next week.